Alrighty, now that we've talked about the basic operations of addition, subtraction, multiplication, and division, and looked at some different contextual ways to explain those operations, we're going to move on to Chapter 10 and talk about developing basic fact fluency within your students. Talking about basic facts for addition and multiplication or other number combinations, we're looking at times when the addends or both factors are less than 10. So that means that basic facts for subtraction division are the corresponding combinations. So 15 minus 8 equals 7 is considered a basic subtraction fact because the corresponding addition parts are both less than 10. The goal with basic facts is to develop fluency. The Common Core State Standards actually describe fluency in students as their ability to flexibly, accurately, efficiently, and appropriately solve problems. So all four of those aspects: flexibly, accurately, efficiently, and appropriately solve problems. Developing fluency of addition and subtraction concepts begins in kindergarten and continues through grade 2. And similarly, fluency with multiplication begins in grade 2. And you hope students to have mastered those concepts and be able to produce them by rote at the end of grade 3. Developing fluency with basic facts really is a developmental process. And while flashcards and time tests can certainly help, they aren't the best way to develop true fluency. Rather, if you can focus more holistically on number sense with students, that's the best way. Of course, you can use flashcards and time tests as tools, but you want to integrate them into a more holistic approach. The developmental process can best be described in the following 3 phases. Phase 1 involves counting strategies. We're using objects to count, or you're verbally counting to determine the answer, and we looked at those strategies in chapters 8 and 9. Phase 2 and Phase 3 are what we're going to focus on in Chapter 10. Phase 2 is reasoning strategies, where you use known information to logically determine an unknown combination. And Phase 3 is mastery, where you produce answers efficiently. This table just shows the developmental process for basic fact mastery for addition and subtraction. It's important to remember that we focus solely on addition first because students can't handle subtraction until they have mastery of addition. And this chart goes through those 3 phases and then associates or shows some of the direct ways that you can teach or have your students demonstrate that they're progressing in those phases of counting, reasoning, and then mastery or retrieval. Over the last century, 3 main approaches have been used to teach the basic facts. We're going to talk a little bit about the pros and cons of each. While many of us, including myself, learn through memorization, and once the basic facts are mastered, I believe in memorization because mastery is having the facts memorized. You want to get to the point where you just know them because that aids in quick and efficient problem solving. Teaching through memorization has the drawback of being very overwhelming, inefficient, and it can result in students being very inflexible in their problem solving and reasoning approaches. And it can really narrow the benefits that students gain in the learning process. So even though you're working towards that, and memorization does result in efficient problem solving, you don't want to teach by strict memorization, which is flashcards and time tests, because the students have no understanding in the process of why those results are yielded. So we want to teach through means that address the why and show the how. One way is through explicit strategies or direct instruction, and that involves modeling effective strategies and giving students practice opportunities to discover their preferred strategies. This technique builds number sense, and here would be an example, showing them that 6 times 8 can be partitioned in equal 5 times 8 plus 1 times 8. Why is that beneficial? Because again, 5s and 10s are anchor numbers, and they're easy for students to understand the products of them, and so they can see if they break it up into something that's easy to reason with mentally and just add 1 extra set, that's the same as saying 6 times 8. Another approach is guided invention, and that focuses on strategies but in more of an open-ended way than explicit instruction. For example, a teacher might post the fact 6 plus 7 on the board and ask the students to explain how they generate the solution to that. One student might think, well, 6 plus 7 is the same as double 6, which is 12, and then just add one more, which is 13. While another student might see, I'm going to try to get to 10 first. So 7 plus 3 will get me to 10, and that leaves 3 more to add. So the key is that you are setting up tasks where the students can notice and apply these number relationships, and then you allow them to share so that all the students witness the possibilities. It's really important as a teacher that you plan experiences for your students that help them to move methodically through the 3 phases of counting, reasoning, and mastery. Eventually, your students are just going to know the facts, and they won't have to invest any cognitive energy to recall them. Research has found that when a strong emphasis is placed on solving problems, students not only become better problem solvers, but they also master more basic facts than students who are in a strictly drill program. Story problems are one way to provide context to help your students understand the situation and apply flexible strategies for doing computation. We've seen this done with addition. It can be done with multiplication. Suppose you give your students a problem. In 3 weeks, we will go to the zoo. In how many days will we go to the zoo then? A problem like this allows students to use known facts like doubling 7 to get 14 and then adding an extra 7 to get to 21. So in addition to story problems, it's going to be really important that you teach your students explicit problem solving techniques, just like I just mentioned with the doubling and then adding an extra to get 3 times a number. Okay, we're going to take a minute and talk about time tests. It's really important to realize that we're talking about time tests for assessing basic facts in the lower primary grades. I'm not talking about practicing time tests to prepare students for the ACT and SAT, because that is a learned and needed skill. But we're talking about using time tests as a means for teaching students the basic facts. They're really not a positive instructional tool, and here are 3 reasons why. First, they do not assess the 4 elements of fact fluency that the Common Core State Standards advocate, which are to flexibly, accurately, efficiently, and appropriately solve problems. In addition, they negatively affect students' number sense and recall of facts. And then lastly, they take up time that could be used in more meaningful learning experiences. Remember, when you're teaching, you're trying to have students use reasoning strategies. And the pressure of a time test thwarts against taking that time to reason and instead puts pressure to quickly recall. And that's fine in a mastery phase, but that is not okay in the teaching phase, where you're trying to encourage them to develop reasoning strategies. So I know I've really emphasized that there are 3 steps that you need to progress through as a student in order to just recall basic facts. The second phase, the reasoning strategy, really is the most important. And we oftentimes expect students to quickly move from phase 1 to phase 3, from counting to memorization. But you have to bridge that gap by teaching your students proper reasoning strategies. So we're going to spend quite a bit of time on different reasoning strategies. It honestly takes many months of exposure to and practice with many different types of reasoning strategies for students to just know their facts. Because A, this allows them to learn flexible problem solving, and B, it also allows them to find the reasoning strategies that they feel the greatest affinity for and what works most for the way that their brain operates. Our textbook discusses 10 different strategies, and we're going to look in detail at several of them. The first strategy is 1 more than and 2 more than a number. Each of the 36 facts that are highlighted in that green and blue chart on the left of the slide that you're looking at has one addend of 1 or 2. And you can see that for each of the numbers from 0 to 9. It's really easy to create story problems where one of the addends is 1 or 2. And when asking about the story problems that you make up, you really should have your students explain, how did you get the answer of 9? And they might say, well, I counted 2 more than 7. Because this is the start of being able to move from counting to reasoning. Another foundational strategy, perhaps the most foundational and important, is combinations of 10. And it's so important because so many other facts can be derived from 10. It's like the primary anchor. So it's really important that you touch on how to form combinations of 10 before the rest of the reasoning strategies we'll consider in the next slides. And here would be an instance of teaching combinations of 10. Say you give the students a problem that says 10 boys and girls are on the bus. How many girls and how many boys could possibly be on the bus? Where the students have to present different answers, and you could have them explain their reasoning strategies as well. Using doubles is another foundational fact that you should teach students in their working towards mastering their basic addition facts. There are 10 doubles from 0 plus 0 to 9 plus 9, and they are all natural anchors, so you should try to create story problems with these numbers to improve student facility within. And there really are so many natural doubles in students' everyday life, like a box of 16 crayons or 12 or 18 eggs. Your hands, the fingers on them form doubles. Spider's legs, the calculation of the days in 2 weeks, the wheels on an 18-wheeler. So there's a lot of opportunities, and those are just a few of them. Like combinations of 10, which we already discussed, 7 plus 3, 6 plus 4, 5 plus 5. The strategy of making 10 is also a critical and reasonable problem-solving strategy that you're going to want to explicitly teach and demonstrate to your students. All of the basic facts that are 20 or less and greater than 10 can all be solved using this making 10 strategy. For instance, if you give your students the problem 8 plus 6, you can show them that this can be solved by taking 2 away from 6 and adding it to 8, so that it's equivalent to 10 plus 4. 10 is a natural anchor. Encourage your students to use it as much as they can. And the making 10 can be used for any powers of 10. So you can use it with bigger numbers. Like if you gave your students 28 plus 7, they can realize that if they take 2 away from 7 to make it 5 and give it to 28, that's the same as saying 30 plus 5. The Make 10 strategy has been used with great success in many Asian countries that routinely outscore us on educational exams. So it's a really great one to teach to your students. Using 5 as an anchor is another foundational reasoning strategy. And it really will help students become intuitive and encourage them to look for 5s in their number problems. So if they see 7 plus 6, they realize, well, 7 is the same as 5 plus 2, 6 is the same as 5 plus 1, and then on top of honing in on those number relationships, they'll be encouraged to use the commutative property and add up 5 and 5 easily to get 10, and 1 and 2 to get 3, and then they'll see that that adds to 13. So it really encourages a much deeper sense of reasoning than just explicit memorization. Another good one is the near doubles property. Basically, near doubles means doubles plus 1. So for like 13, 21, 31, the students might see, okay, for 13, for instance, I'm going to double 6 and add 1. And for 15, I will double 7 and add 1, and so on. I like this property because the doubles are an easy foundational fact that you're going to teach early on, and this scaffolds and builds upon it so the students can attach something new to something they already know, and so it will cement much more quickly in their brains. Subtraction facts prove to be more difficult for students than addition. And perhaps that's because in the past, as teachers, we spend a lot of time teaching students to count down rather than to reason. But 2 effective reasoning techniques are the think addition and down under 10 technique. We've seen the think addition technique in a prior chapter. If you give a students a problem of 13 minus 5, you ask them to translate that in their brain as 5 plus what equals 13, so they can think of their addition facts and strategies. How does down under 10 work? Well, you use 10 effectively as an anchor again. You start with 14 and you see how many you have to move down on a number line to get to 10, and then how many more you need to move down to take away that desired number. So 14 minus 8 would be, you'd go down 4 to get to 10, then an additional 2 to get to 8. 4 plus 2 is 6. So in some ways, it's incorporating addition as well. There's one other strategy that I'd like you to look at in your textbooks on page 208. It's called the take from 10 technique. Familiarize yourself with it. It's been a great technique that's been used in high performing countries other than the US. So I think it would be a great one for you to familiarize yourself with, particularly if you are going to have students in your classroom whose home country is not the United States. And that's becoming a more and more common thing. We spent a lot of time talking about addition and lastly subtraction, so we're going to move on to reasoning strategies for multiplication and division now. Story problems in multiplication are equally important as they were with addition. You really want to be stressing with multiplication the commutative property because it cuts memorization in half. For instance, you want to make sure you always show that 2 by 8 in an array is the same as 8 by 2. And so the students have so much less to memorize. Instead of moving in numerical order through multiplication facts, which is typically done in the classroom, a more effective approach is to start with the facts that build on students' strengths and prior knowledge. So a great place to start would be the 2's, which are just doubling, and 5, which is an anchor, and even perhaps 10, which is another anchor. These facts connect to students' experiences with skip counting and addition doubles, as I had mentioned. And one way to really help them to understand and connect what 2 times something, specifically maybe 2 times 7, equals is to show them it's the same as 7 plus 7. With the 5's, you can do skip counting on a number line to show the products, but you could also use a clock as a really effective and relevant way to demonstrate multiplication by 5. Zeros and ones are important to also show students, and don't just teach them in a strict rule manner, like 0 times anything is 0. Show them through a contextualized problem. Perhaps you would want to say there are 7 bowls for apple slices. Each bowl is empty. How many slices are there total? And then students are automatically able to see and instead of just memorizing a rule. So what about the other less intuitive multiplication facts? Let's discuss 9's. 9's can be a little tricky, but they can't be derived from 10's. Let's say you ask students to find what is 4 times 9. If you show them that they can calculate 4 times 10 and then just take away one of those groups of 4, they'll end up realizing, oh, 4 times 9 is 36. The 9's also have a nifty trick with fingers that can be used. If you were doing 4 times 9 and students hold out their hands, if they put down their 4th finger, they'll actually see 3 and then 6 fingers left representing put together 36. And that will work for any of the numbers up to 9 times 10. What about the other facts? Arrays really are a powerful way to show how to use the distributive property to partition a multiplication problem into other recognizable problems. So for the 7's, for instance, if you had 7 times 7, you could easily show a student how that's the same as 5 times 7, which is an easy anchor of 35, and then 2 times 7 added to that, which relates to their doubles. So partitioning is another great foundational strategy for relating known and easy facts to the more complicated ones. Double and double again is another one, and that works for any of the basic facts where 4 and 8 are involved because they're just going to double and then double again. Double and one more works when 3 is one of the factors. So those are some great strategies that can work for multiple multiplication facts. So what about division? Well, with subtraction, we encourage think addition, and the same is true for division, but we're going to encourage students to think multiplication. So when they see 36 divided by 4, they're going to think 4 times what is 36, and they're going to do the double and double again strategy because they have learned that as an explicit approach to 4's. When students just know a fact or they can apply a reasoning strategy so fast that they almost don't realize that they have done so, they've reached phase 3, which is mastery. The Common Core State Standards of Math refer to the mastery phase as know from memory. Repeated experiences with all the reasoning strategies that we discuss can really effectively help students to get to this place, much more so than the old school way of just memorizing and doing timed tests where reasoning wasn't incorporated at all. Games and activities that focus on reasoning strategies are extremely effective in helping students to get to this point. Helping students to become fluent with their basic facts in addition, subtraction, multiplication, division is absolutely imperative. And I have seen the repercussions of not getting students to this point at the college level, where students are still trying to recall their basic facts, wasting a lot of cognitive energy on the basic facts to the point where they do not have the energy or ability to solve a more complicated problem because they have to spend that time on what should have already been a master fact, and it sets those students up for eventual failure. So, as an elementary school teacher, I would encourage you to use games over and over again to provide students with repeated experiences to learn their facts. As you use these games, remember to focus on related clusters of facts and on what individual students need to practice. I specifically love activity 10.17, which is shown on your slide, and it's also in your e-text. It's such an excellent one to have your students try when they are at the mastery or fluency phase, and it's on page 215 specifically. I also think you need to check out table 10.2 on pages 216 to 217. It shows you how to adapt different basic games like bingo and Connect 4 to teach basic fact mastery. So does drill, having your students just produce answers to a collection of basic fact problems, either addition, subtraction, multiplication, division, does that have a place? It does, and it's useful when students are moving from strategy to fluency because it is a way to help them get to that memorization point. They already have the reasoning strategies down, but they need to improve on just knowing and producing the answers very quickly. So you can use some drill, but you want to make sure that when you do that the problems are limited and there's a great amount of variety. If students have not mastered their basic facts by 3rd grade, addition facts by 3rd grade, that is, and multiplication facts by 4th grade, then they're going to be in need of intervention to help them master. You really want to focus on taking inventory first of what they know and don't know, then focus on the unknown facts, but do build in opportunities for them to experience success so they don't get discouraged, because that will bolster hope and it will continue to reinforce what they do know and find opportunities to build on what they do know to bridge that gap to what they do not know. To wrap up, let's talk about some of the do's and don'ts to teaching the basic facts. Some of the do's. Ask your students to self-monitor. You want them to be in tune to what they do and don't know, and that's going to help you to focus on helping them to master and to reason through what they do not know. Help them to focus on self-improvement. Make sure when you do use drill that it's in short time segments, 5 to 10 minutes. And make sure that you work on the facts over time, that you give students lots of experiences with varied reasoning strategies. Involve families. You know, parents are probably going to be used to the way that they learned, and that was probably through flashcards and timed tests. You need to expose them to these new and effective techniques and perhaps give them worksheets, suggestions, so that they can work through these effective strategies at home with their children. When you do use drill, make it enjoyable. Maybe attach it to a game. Try to use technology. You can use calculators, specifically maybe when teaching students to count by 5s or to skip by 10s. You don't want to rely on it heavily because students do need to have good numerical sense, and it can be used to their detriment, but use it here and there when appropriate. Some of the don'ts. Don't use lone time tests. Do not use public comparison of mastery of facts because that'll make students feel self-conscious. You don't want to proceed through facts in order from 0 to 9, but rather do 2, 5, 10, 1, and 0, and then show how those can be used to master the rest of the facts. You don't want to move to memorization quickly. Remember, students need to have the reasoning strategies done first, and then they will just know or beat the memorization phase. And that's when you can incorporate some opportunities for drill, and you could use some flashcards, but that's because students have already gone through all the reasoning steps. Don't use facts as a barrier to good mathematics. Remember, the facts are supposed to help students do rich and good mathematics problems, so use them as a way to scaffold and get to that point.